So in example 1, our two functions are f of x is equal to 1 over x plus 3, and g of x equal to x over the square root of x plus 4. Okay. Well, let's talk about the domain of these two functions first, okay? Before we add them, subtract them, multiply and divide them. The domain of f of x, I realize there's not a lot of space for you to write on this handout. Okay? The domain of f of x is all real numbers except x equals -3, right? So you can write the domain of f of x is x cannot equal -3, right? The domain of g of x you may have to write it at the very top of your paper, some of the stuff. The domain of g of x, well, we have a square root, right? And so usually when we have square root, we say the radicand has to be greater than or equal to 0, right? But in this case, the radicand can't equal 0 because the square root's in the denominator all by itself, right? There's nothing else there except for the square root. So if x is equal to -4, -4 plus 4 is 0, square root of 0 is 0, and now you're dividing by 0. So x has to be strictly greater than, x plus 4 has to be strictly greater than 0 when the square root is in the denominator all by itself. And now when you subtract 4 from both sides, you get x has to be greater than -4. Okay. So when we combine the two functions, f plus g, f minus g, f times g, f divided by g, right? The domain for those situations is the intersection of these two domains, right? X cannot equal -3, and x has to be greater than -4. That's not an or. We're joining with the union symbol. That's an and. It's intersection. Okay? So if we draw a real number line for the variable x, and we label -4, -3, -2, -1, and so forth, okay? For x greater than -4, right, you put an open circle on the -4, and we color everything to the right, don't we? For x not equal to -3, I'm going to draw this x not equal to -3 on top, up above. We put an open circle on -3, and we shade everything to the left and to the right of -3, right? So the domain of f of x and g of x together, right, when we combine them in one of those 4 different ways, is the intersection of these two graphs. And what's the intersection of these two graphs? Well, there's nothing to the left of -4 on the bottom graph, so we exclude everything to the left of -4. There's an open circle on -4 here, so we're going to have an open circle here. And then going to the right, we have everything to the right of -4 in both graphs except at -1, -3. -3 is not in the domain of f of x. So we got to put an open circle at -3, and then we can shade everything in to the right. So when you combine these, when you take the intersection, it's the intersection, not the union. So when you take the intersection of these two graphs, right, there's nothing to the left of -4, because there's nothing to the left of -4 here. There's an open circle at -4, because -4 is in the domain of f of x, but not g of x. So there's an open circle. And there's an open circle at -3, because -3 is in the domain of g of x, but not f of x. But then everything else, all the other numbers, are in the domain of both functions. So for the first three examples, the domain is going to be parentheses -4, comma -3, parentheses union -3 to infinity. Okay? That's going to be the domain for f plus g, f minus g, and f times g. Okay? We're going to have one additional restriction for f divided by g. Okay? So f plus g of x, what's that equal to? Right, this is what we're doing right here. F plus g of x, that's equal to f of x plus g of x. F of x is equal to 1 over x plus 3. And g of x is equal to x over the square root of x plus 4. Now you got two quotients, you need a common denominator. What's the common denominator? X plus 3 times the square root of x plus 4. So this first quotient, we multiply top and bottom by square root of x plus 4. And the second quotient, we multiply top and bottom by x plus 3. So we're left with, in the denominator, we're left with x plus 3 times the square root of x plus 4. So that's what f plus g of x simplifies to. Okay. What's the domain of this function? We already calculated it. -4 to -3, union -3 to infinity. Okay. Yes, sir.
Do you have an extra set of notes?
Oh, certainly. I would never leave you out. Yep. All right. So any questions on that? So next we have f minus g of x which is equal to f of x minus g of x, which is going to look similar to this, except we have a minus sign here, right? We have 1 over x plus 3 minus x over the square root of x plus 4. Same thing, common denominator is x plus 3 times the square root of x plus 4. And so we multiply top and bottom of the first quotient by x square root of x plus 4. And then we multiply top and bottom of the second one by x plus 3. What's the domain? Same as this. F plus G, F minus G, and F times G all have the same domain. F over G of x is equal to F of x divided by G of x. Well, F of x is 1 over x plus 3, and G of x is x divided by x plus 4. Say what? Oh, I'm sorry. I did get ahead of myself, didn't I? Thank you, Rachel. Yeah, F G of x is equal to F of x times G of x. All right. So now F of x is equal to 1 over x plus 3, and G of x is x over square root of x plus 4. And you know, when you multiply two quotients or two fractions, you just multiply straight across, right? So 1 times x is x, and then we have x plus 3 times the square root of x plus 4. And the domain is the same as in the first two cases. Nothing has changed. Okay? Now we can do the division. F over G of x is equal to F of x divided by G of x. F of x is 1 over x plus 3. G of x is x over the square root of x plus 4. Now you got to do the Keats switch flip thing, right? This is a complex fraction. This numerator divided by this denominator. When you do that, you got to do the Keats switch flip, and you end up with square root of x plus 4 in the numerator over x times x plus 3 in the denominator. Okay. So we have one additional restriction, right, in the domain of f over g of x. Okay? You notice that g of 0 is equal to 0 over the square root of 0 plus 4, which is 0 over 2, which is equal to 0, right? You can't, you put in, try to evaluate this function at x equals 0, you have g of 0 in the denominator, which is equal to 0, and you can't divide by 0, right? Division by 0 is undefined. So, for f over g of x, right, we have the addition restriction, x can't equal 0, right? X equals 0 is not in the domain. So we have to remove 0 from this interval, right? From this domain. How do we do it? So 0 is between -3 and infinity. So we're going to have an additional set of parentheses, right? It's going to go from -3 to 0, and then union 0 to infinity. So the domain for f over g of x, we're going to have the first interval from -4 to -3. And then we got to split this interval up. Goes from -3 to 0, and then from 0 to infinity. Because we got to eliminate 0, right, from this set of numbers. Okay, does that make sense? We have one additional restriction, right? X can't equal 0. All right, any questions on that? Okay. So if you flip over to page 2, we got to evaluate f plus g of 5, right? X is equal to 5. Now there's actually two ways to do this, okay? One way is on a previous page we found f plus g of x, right? So you could just put in 5 in for x in f plus g of x on a previous page, or this is also equal to f of 5 plus g of 5. And now you evaluate f of 5 and g of 5. Well, from the previous page, f of 5 is equal to 1 over 5 plus 3, and g of 5 is equal to 5 over 5 square root of 5 plus 4. Well, this is equal to 1/8 plus 5 plus 4 is 9, square root of 9 is 3, so we have 5/3. Now you have 1/8 plus 5/3. Common denominator is 24. And so after you give both those fractions the common denominator 24 and add them together, I got 43/24. In mathematics, we prefer an improper fraction, right? If you got something else, let me know. So f plus g of 5 is equal to 43/24. All right, in example 2, common air pollutant responsible for acid rain is sulfur dioxide. Emissions of SO2 from burning coal during year X are computed by f of x in the table. Emissions of SO2 from burning oil are computed by g of x. Amounts are given in millions of tons. Okay. So in 1860, emissions of SO2 from burning coal were 2.4 million tons. And since they weren't burning oil yet, emissions were 0 from burning oil. Okay.
Do you want to do the one under f plus g of 5?
Oh, why am I missing these things? Okay. Thank you, miss. F G of 0 is f of 0 times g of 0. I missed it when I worked these out. So what's f of 0? F of 0 is 1 over 0 plus 3, and g of 0 is 0 over square root of 0 plus 4. What's the answer going to be? 0, right? Because this first fraction is equal to 1/3. 0 plus 4 is 4, and square root of 4 is 2, and 0 divided by 2 is still 0. So this is just equal to 0. All right. I missed it completely when I worked these out. All right. So now we can do example 2. So you're asked to evaluate f plus g of 1970. Right? So we're adding two functions, right? So this is equal to f of 1970 plus g of 1970. Well, what's f of 1970 equal to? 32. Right, so here's f of x. X is 1970. So f of 1970 is equal to 32.4. And g of 1970 is equal to 17.6. So f of 1970 is equal to 32.4. And g of 1970 is equal to 17.6. And when you add those two together, you get 50. 50 what? Million tons of what? Water, beer,
Sulfur dioxide.
yeah. SO2, right? So 50 million tons of SO2. This says interpret your answer. Okay. 50 million tons of SO2 were emitted from burning coal and oil in 1970. Okay? That is the interpretation. Any questions on that? Okay. Composite functions. Taking the composite of one function with another. This is what I remember from my from my college entrance exam when I was a student in high school. We were seeing these things on it. Okay. So, well, I'm not going to write it out. So, we denote the composition of the function f with g by this notation. This open circle here is not a multiplication. This is what's called a composite operator. So you're taking the composite of function f with g as a function of x. By definition, that's equal to f of g of x. Okay? So, example 3, you're given f of x is equal to 2 over x plus 3, and g of x is equal to 5 minus x. Okay. So in A, you got to find the composition of the function f with g as a function of x. Okay. Well, by definition, that is equal to f of g of x. So step number 1 is to replace g of x with what it's equal to. That's called, g of x is called the inner function because it's inside f of x. So step number 1, replace g of x with what it's equal to. Well, it's equal to 5 minus x. So now you got to evaluate f of 5 minus x. Well, we know how to do that. You just replace x in f of x with 5 minus x. So when you do that, you have 2 over 5 minus x plus 3. And when you simplify, 5 plus 3 is 8, so you have 2 over 8 minus x. So that's the composition of the function f with the function g as a function of x. Okay? You should try to work out these next 4 on your own before class tomorrow, and we'll pick it up here tomorrow. Remember, we have our quiz on 2.2 and 2.3, or 2.3 and 2.4 tomorrow.